hope we are all doing well. Today we are going to talk about linear search, which is under algorithm in computational thinking. It is going to be a fun-filled lesson, so stay tuned. This is group 35 of ITE 300P. Okay, now we find ourselves asking what the meaning of linear search is. Before we can take a deeper look at what linear search is, we need to first of all break the words down. And in breaking linear search down, we found out that it is made up of two words, and those two words are linear and search. So we then take the definition of linear. What is linear? Linear is just something which is arranged or extending along a straight line, or we can also say linear is progressing from one stage to the other in single series of steps or in a sequential manner. Good. I hope we all understand what linear is. Now let's move on to search. Search is a process of finding something particular in a list of other items. So let's say, for example, you are finding your pencil in a list or among your pens. We say that you are searching for it. Okay, searching is a daily routine that we go through each and every day of our life. We always have the need to search for items like pencils, pens, car keys, phone chargers, etc. The same applies to a computer. A computer searches for lots of stuffs and data that are stored on it if the user requests for it. So just like humans, the computer has a way of searching for items, as we also have a way of searching for items. There are two main ways that a computer searches or uses to search for an item. The first one is linear search, which we are going to treat about in this topic, and the second one is binary search, which we will treat in a later topic. So now we come to the definition of linear search. What then is linear search? From our earlier definitions of both linear and search, we say linear is something that is in a straight line, and search is when we are looking for something. So it simply means that it is a basic way of searching for items that involves a sequential manner. That is, by going through the items from the first through to the last without omitting any of the items until we are able to locate the item we are looking for. In the case of linear search, all the items are checked one by one until a match is found. If a match is found, then the item is returned. If it is not found, then it continues till it gets to the end of the list, and then it terminates. It is mostly used to search for items that have not been ordered. That is an unordered list. In an unordered list, the items are not arranged in a particular order. So what happens is that you don't know the location of any of the items. So let's say, for example, you are searching for a book. So you think about how you will instruct someone to search for a book. Let's say, for example, the book is on a randomly ordered bookcase in someone's bedroom, or in the fiction section at a library. What would the instructions be? Would they be the same in both cases? I doubt that, because they are in different places. So definitely the instructions aren't going to be the same in both cases. The same applies to linear search. So in this starter activity, we are going to think, write, pair, and then share your answers with your classmates. So I want you to all think about this particular scenario. Will the questions in these cases be the same, or they are going to be different? Write your answers down. Then after that, you can pair and share your answers with each other. Let us move on. Linear search is called linear because it goes through every single digit in its list as represented in the particular items, as I said earlier. So it goes through within each list one by one, and in so doing, it does not omit any item. It needs to go through each and every item till the item is found. So now, in this lesson, we are going to first of all identify why computers often need to search for data, and then how linear search is used for finding the position of an item in a list of items. And also, we are going to perform a linear search to find the position of items in a list. So without wasting much time, let's take another example of finding items in a list of other items. Whenever there are lots of items, it is important to be able to find the one you need. For example, you might need to look through a clothing reel to find an item in your size, as stated in this picture, or you search through a pack of cards for a particular item or for the particular card you are looking for. So computers also need to search through sequences of data all the time. For example, trying to find a file with a particular name on your computer. Another example is using a search engine to find websites on the internet that match certain keywords. When faced with a search algorithm, you either have to deal with ordered or unordered sequence of data. As I said earlier, an unordered list is a list that is not arranged in a particular order, and ordered list is the opposite of unordered list, which simply means it is arranged in a particular order. So in this case, linear search is used to locate items which are in an unordered list, because in an unordered list we don't know the particular location of any of the items because they are arranged in a mixed order. So we are going to continue. Linear search is just an algorithm that involves checking each item in a list or sequence of data one at a time, hence the word linear, to see if it is the right item. If you have a list that is not in order, a linear search is the only reasonable way to search through it. So in the next slide, we are going to perform some activity just to demonstrate how linear search works. Okay, now what do you see before you? Okay, these are disposable plastic cups, and we have 9 of them over here. So in these disposable plastic cups, what happens is that there are numbers hidden under each of them, and what we are supposed to do is find a particular number. And how do we find a particular number? Using the linear search, we need to go through and raise each of the cups one by one, trying to locate the particular number. If it is found, then we locate the cup under which it is found and return the number. If it is not found, we continue till we get to the end and then terminate the process. So without wasting much time, let's get on with this activity. So first of all, we are supposed to find the number 126. In finding the number 126, we need to start from the first cup, which is cup 1. We take a look at cup 1, and then we raise the cup to see whether we can locate number 126 under it. We raise it and we see only 27, which is not equal to 126. So what do? We place that cap back and then move to the next cap, which is cap 2. So in cap 2, we raise that cap also, and we find number 358 under it. Is it equal to 126? No, it is not. So what do? We place it back and then move to the next cap, which is cap 3. Now at cap 3, we raise cap 3, we look under it, it is the number 62. 62 is not what we are looking for. We are looking for 126. So we place the cap 3 back and then move to cap 4. We open cap 4, we see number 9 under it. Are we looking for number 9? No. So we move on to the next cap. But first of all, we need to place cap 4 down. Cap 4 is placed down and then cap 5 is raised. We look under cap 5, we see number 412, which isn't what we are looking for. So we place cap 5 down and then raise cap 6. We raise cap 6, and here we have, that is the number we are looking for. This is 126. So now all we need to do is just give the location of this particular cap in which the number is found, which is cap 6, and then we stop the search. As simple as that. That is how a linear search in algorithm works. I hope this little activity has been able to demonstrate to you how linear search works in algorithm. Alright, so we continue. These are the steps in implementing linear search. The instruction for performing a linear search can be written as 1. We take a list of data and an item that is being searched for. In the example that we did above, the list of data are the numbers under the caps, and the data we are looking for is the number 126. Now, the next step is to repeat the steps below, A, B, and C. And in doing so, we start from the first item in the list and you look, is it equal to the item we are looking for? No. If it is not equal to it, then we move on to the next item. Then we move on to B. If the item at the current position isn't equal, we continue. We continue searching until we get to the end of the list. If we find the item, we locate its position. If we do not find the item, we terminate the algorithm. That is how the linear search is implemented in an algorithm. Now, we are going to take a look at some of the advantages and disadvantages of a linear search. Let's first of all take a look at advantages of a linear search. In advantages of a linear search, you can see that it will perform fast searches if the amount of data is from small to medium. With today's powerful computers, small to medium arrays can be searched relatively quickly. This is because it needs to search through each item one by one. So if the item is bigger, it is going to take a longer time. So depending on the size of the item, it will search through it quickly. And the list does not need to be sorted also. Unlike in other searches like the binary search, linear search does not require you to sort the list, that is, arrange them in alphabetical, numerical, descending, ascending order. You don't have to do that. You just go ahead and start with your search, which helps you to save some time. And it is also not affected by insertion and deletions. In this case, you don't have to insert or delete any item from the list. This is because it doesn't require that, and it may have to be reordered or so or any other thing, but this sometimes means a linear search will be more efficient. We now take a look at a disadvantage of linear search. In the disadvantage, we see that it is going to be very slow if the list is huge or large. For example, when searching through a database of everyone in the Ashanti region to find a particular name or a particular person, you will realize that it might take a necessarily long time to search through 11 million people before you find the one you wanted. This is a very big disadvantage when we are looking in big chunks of data. So this is the only disadvantage of linear search. I hope we all understand what I have said so far. Thank you and have a nice day.